This video is going to cover the material and some examples from section 10.6, which is on solving radical equations. Our two objectives will be to learn and understand the use of the principle of powers, and to learn to solve radical equations with one or two terms. Really should say that there. One or two radical terms. So the principle of powers. Radical equation is an equation in which the variable appears in the radicand. So the variable is stuck under a radical sign. It can either be one radical expression or two. Actually, you could have a lot, but we'll only do one or two. And the principle of powers says that if you have an equation that's already balanced, equal on each side, then if you raise it to a power, say n, if you do both sides, the entire side, not piece by piece, but as a side, raise it to a power, then you still are in balance. You still have an equation. So this is going to be a really powerful tool for us when we solve radical equations. So, first example, we're going to solve the square root of m plus 3 equals 9. So I want to get this square root of m by itself over here. So I'm going to subtract 3 from both sides, and I'm going to get the square root of m equals 6. And now the principle of powers tells me that if I raise that side, the square root of m, to the second power, and I raise 6 to the second power, I will still have an equation. So the square root of m squared is m equals 6 squared, which is 36. That is the answer to our equation, but I want us to go back and check it. I want you to check every one of these. The reason being that on even powers, sometimes it will show you an answer that does not actually work in the original equation. So you go back to the original equation and you put in your answer and you check it. 36, 6 plus 3 equals 9, 9 equals 9. So that checks. So, just like I said, and big caution, raising both sides of an equation to an even power may not actually produce an equivalent equation. So you may not actually get the correct answer for your variable. So you have to go back and check it. It gives you a possible answer. You can't call it an answer until you've checked it in the original equation. So here's the process written down step by step. I really suggest writing this down, maybe on an index card, and having it out in front of you when you first start working problems so you can refer back to it, and then kind of wean yourself off of needing to refer back to the process as you learn more and more. And so this is basically what we did on the example. You isolate the radical term. So you want to get the radical term all by itself on one side of the equation. Everything else goes to the other side. And then you use the principle of powers. So basically you raise each side of the equation to the same power, and the power that you want to use is the index of the radical term, because that's the one that'll clear out the radical. You'll get an equation that results from that, and you use the skills that you've already learned in equation solving to solve that, and then you check any possible solution in the original equation. Again, this process gives you possible solutions, but they are not, you can't say that's a solution until after you have checked it. So here's another where we have x equals the square root of x plus 5 plus 1. Now I know your gut reaction is get everything with an x on one side, but in this case you don't want to. You want to isolate the radical term. So you're going to isolate that square root of x plus 5 by subtracting 1 from both sides. And now that we've done that, we can raise both sides of the equation. Notice I can't just raise x to the second power and 1 to the second power. I have to raise the entire thing all as one unit to the second power. Do the same to the other side. And this I'm going to have to FOIL out. So I'm going to FOIL out x minus 1 times x minus 1. And I'm going to get x squared minus 2x plus 1 equals x plus 5. And now I want to get x, I want to solve for x, and it's a quadratic equation because I have a second power in it. And to solve quadratic equations, we use the principle of zero products, which tells us that we want that if we have two things multiplied together, equal to 0, either one equals 0 or the other equals 0. The only way to do that is to have one side of our equation be 0. So I'm going to subtract x and subtract 5 from both sides of this equation, and I will get x squared minus 3x minus 4 equals 0. And then I will factor this side. So we know we have x in each place. We know we have a plus and a minus because we're multiplying to a negative number. And so we know that we want two factors of 4 whose difference is 3. That's 4 and 1. And we know 4 has to be the negative one because the middle term is negative. And now we'll set each of those equal to 0. We'll get x equals negative 1 and x equals 4. So let's check both of those in the original equation. Okay? Check. So, negative 1 equals the square root of negative 1 plus 5 which is 4, plus 1. So negative 1 equals 2 plus 1, negative 1 equals 3. That does not check, so that is not a solution. The next one, we'll say 4 equals the square root of 4 plus 5, which is 9, plus 1. 4 equals 3 plus 1. 4 equals 4. That checks. So out of the two possible solutions we got, only one of them is a true solution of the equation. So our answer is x equals 4. Okay, this next one, we have a rational exponent. We're going to use the principle of powers on this one also. And we're going to do it by isolating the 3x plus 4 to the 1/3 power on one side, moving the 2 to the other side. So we just added 2 to both sides. Okay? And to get this to be 1, we have to raise it to the third power. Remember, the 3, if we had changed this to a radical expression, which we very well could have, and if you're more comfortable doing it that way, feel free to. This would have been the index, and we're always going to raise it to the power that is the same as the index. So that means we'll raise this to the third power. So we'll get 3x plus 4 equals 8. 3x equals 4, and x equals 4/3. So let's check that. Okay, I'll check in red. So we have 3 times 4/3 plus 4 to the 1/3 power minus 2 equals 0. So that's, these two cancel out and you'll have 4 plus 4, or 8, to the 1/3 power minus 2 equals 0. Well, this is the cube root of 8 minus 2 equals 0. And the cube root of 8 is 2. So 2 minus 2 equals 0. 0 does in fact equal 0. So this is the solution of the equation. Now when you have 2 or more radical terms, you isolate one of the radical terms. You just choose one, put it on one side all by itself, and use the principle of powers. So find the index of that one you've isolated, raise each side, the entire side as a unit to that power, and simplify from there. But if you still have a radical, you're going to have to go through again, and you're going to have to keep going through and doing this until you're completely clear of radicals. Okay? You'll solve the equation that you get, and then you'll check the possible solutions in the original equation to see which of the possible solutions are actual solutions to you. So here we go. We're going to do another color just to be fun. X plus 3 minus root of x minus 2 equals 1. So I'm going to start by isolating x plus 3, the square root of x plus 3 on this side, which means I'll move the square root of x minus 2 over to the other side, add it to both sides. And now I'm going to raise each side to the second power. This is a binomial squared. So let's just do our work over here about how to square this binomial. We're going to use the FOIL method, and it'll be the square root of x minus 2 plus 1 times the square root of x minus 2 plus 1. First times first gives us x minus 2. Because it gives us square root of x minus 2 times the square root of x minus 2, which is the square root of x minus 2 squared, which is x minus 2. Plus, outer gives us the square root of x minus 2. Inner gives us the square root of x minus 2. And last gives us 1. So that's what's going to go over here. So now we have x plus 3 equals, and I'm going to do some combining here, okay? We have x right here. We have 2 square roots of x minus 2. And we have minus 2 and plus 1, so minus 1. So now I have a radical term left. It's this square root of x minus 2. So now I'm going to add 1 and subtract x to move everything to the other side and isolate that radical term. And what am I going to get? I am going to get, these cancel out, I get 4 equals 2 square roots of x minus 2. Divide both sides by 2, and we get 2 equals the square root of x minus 2. Raise both sides now to the second power, because the radical term we have is a square root. Its index is 2, so we raise it to the power of 2. And we get, I'm coming up here, we get 4 equals x minus 2. X, therefore, equals 6. Now, we absolutely have to check that in the original equation, okay? So, let me get a slide up with that on it. Hold on. Okay, so here we have the original equation, and the answer we got was x equals 6. So we're going to put that 6 into the original equation. 6 plus 3 minus the square root of 6 minus 2 equals 1. So we get the square root of 9 minus the square root of 4 equals 1. Square root of 9 is 3 minus the square root of 4 is 2 equals 1. 1 does indeed equal 1. It checks. So our answer is x equals 6. Very long and involved process when you have more than one radical term.